Thank you very much for joining. My name is Martin Sandren, and I'm the meetup manager for the Amsterdam DI meetup. It's been running for, I think we're into our 5th year now. Originally, we did a lot of physical meetups, but then came COVID, and since then we've done quite a lot of virtual ones. And today we have Silverfort visiting us to talk about advanced attacks and how to protect yourself. So with that introduction, Jasper, you want to get started? Jasper, are you able to? You might be on mute. Or...
I'm still on mute, sorry.
So,
first of all, thanks for having us, Martin. It's a pleasure to be here, and as well for everybody on the call. My best wishes for 2023. We're still in the period where we can say that, right? So, yeah, that's it. What we're going to do today is a pretty technical presentation / demo that will be hosted by David de Mitz, our system engineer for the Benelux. And we'd be happy to invite any kind of questions during the demo. We have some people monitoring the chat as well. If there are questions, feel free to ask them there. That said, before I give it to Davey, I think it's important to set the scene and convey to you like why we think it is important what we do. So when we look at identity protection, we see, and most of you are well known with that field. A lot of the companies now realize that identity protection is a top priority. Yet we still see that identity-based attacks are rising. If we look at the Verizon data breach report, 82% of breaches involve human element, 50% include stolen credentials. Gartner says similar things. Morgan Stanley says that IAM is currently the #1 priority for security spending. And we see that most companies already use MFA. So why is this problem still growing? Well, that is what we see is a lot of companies nowadays spend a lot of money on really good tools like your Oktas, like your Microsofts, like your Ping Identity. Those are really good tools to protect your front door. Of what we often see though is that money that is spent on the front door does not protect alternative attack vectors like PSExec, like file shares, like things that are not that easy to integrate with for your IAM vendors. So that is where we come in. What we do is we take that solution and we do not replace it, but rather we extend the MFA that is provided already by your IAM system on modern identity security across all of the users, systems, and environments you have. So that includes things like PSExec, things like file share, things like non-human identities as well. What Gartner says about that is, and I think the last sentence here is important, Silverfort can extend access management controls to a wide range of systems without requiring code changes, software agents, or proxies. That said, I promised that it would be a technical presentation. So I'm going to hand it to Davey here. We will take you through the concept. We will show you how it works. And yeah.
All right. Thanks, Jasper. Good afternoon, everybody. I hope you can see my screen. Can someone confirm? Yeah. All right. Cool. So we're going to do it a bit differently today. I'm going to start off with showing a few, let's say, simple examples of typical use cases of what Silverfort can do in an environment, and then we'll show up a few slides explaining how to position Silverfort, how it fits in your security stack compared to other toolings that you have. show a bit about the architecture and use cases, and then we're going to finalize with some real live attack scenarios on the demo environment. I'm going to do it live, so I hope everything works fine. It's not pre-recorded, so it's a challenge, but yeah, we'll see. You never know with some attacks if they work or not, but it should work out fine. So let's start off with explaining a bit on our product itself. What you see here is a real live dashboard of our demo environment. So if I refresh the page, you just see it's a real environment, and what we show here is that the authentications from an environment are actually passing through our system. Now, what Jasper already said, that you are familiar with well-known identity provider solutions, IAM solutions in the field, and what we do is basically extend whatever security they provide furthermore down your whole environment, like who's accessing which resource, what kind of access is required, and provide additional validation or additional policy and additional security on top of that when necessary. And this is what you see here. So at the left side, we can see a few well-known IDP solutions. It's no surprise, I think, that Microsoft is the biggest one. So we have Active Directory, Azure AD, ADFS. But we also see that, for example, this environment is also linked to a ping federate IDP. Okta is an option. This is not linked in this environment, but these are the IDPs that we currently support, where we can hook in to get all the authentication information from there, right? So whenever a user logs in, for example, to Active Directory, that authentication comes in, we see it, and we can act on it. That's how you should position ourselves for the moment. The authentication is passing through our engine. A lot of things happen here, but basically it's a flow of a policy basically applied to the authentications, which provides the capabilities of insights, but also capabilities of adding an additional layer of security, for example, by applying MFA. That's what we're going to do today as well. We're going to apply MFA on certain interfaces. Jasper already talked about, for example, PSExec, remote PowerShell, remote desktop. But we do this without touching the clients, without touching the servers or the machines that we're trying to reach. The way we do it is completely fully based on the IDP layer. We have also some risk analysis going on, looking at behavior in the environment. I'll try to show you a few of this as well. And then, of course, you're accessing systems and resources that are running in the environment. That can be, like I said, simple remote desktop to another system, but it can be also file shares, database access, other systems, industrial systems, which is typically more challenging because then there as well, there's no capability, no way of adding an agent. And for us, it's more easy to secure because we don't need that agent, for example. So a whole bunch of interfaces that we can protect without touching them, without really making any changes. So what I have here is, let me just minimize this one as well, is I have my phone mirrored. So I have a few MFA applications here because what it's important to know, what Jasper said is true. We have strong relationship with Microsoft. We integrate with IDP solutions, not only to get the authentications, but we also use we allow to use different multi-factor authentication solutions to provide that step of authentication. So we have a Silverfort application that we can use for the push notifications, let's say, but we can also use, for example, Microsoft Authenticator, Okta, Duo, etc., to validate if an additional MFA is required for whatever access your Silverfort wants to apply MFA. So this means that, and you will see when I open a few connections, that multiple applications will ask me to provide MFA. Of course, it's demo. We do it just for demo purposes. In real life, you would make a selection, or for example, if you're already standardized on Okta, you would use Okta. We see a lot of companies where we come in, they have Microsoft Authenticator and they keep using it. But then, for example, administrators from the IT department, they use the Silverfort application because there's a little bit more context in that application. It really depends on your environment, but just know that we're open to that and you can select whatever you want to use in that. Let me just minimize this. Yeah, okay, there we go. So I have a Windows environment. So my workstation, let's say, open here on this machine. So I'm in our demo environment. On this machine, I am logged into a domain. So my username is Davy. The domain I am in, you can call this from the from the CLI, like this. So I'm in the domain ad.ac.aws.silverfort.io. For example, I can check if I have Kerberos tickets right now, which I do. I have these because I logged into this machine. So it's just basically some KRB TGT tickets, some LDAP tickets from domain controllers. So nothing special here, but this proves that I am on a machine that is actually domain joined. And this means that the credentials that I entered to access this machine are actually now cached in memory. Windows stores these credentials or the hashes of these credentials in several forms, depending on what you're trying for what is needed. But one of the examples is when you're opening from here another remote desktop connection or opening a file share, it will use those cache credentials to access or to provide your credentials and provide you single sign-on experience. So you don't need to enter your credentials all the time as a user when you're working in a domain. And this is exactly where we want to provide that additional insights, that capability of securing that connection. Because when you put yourself in the position from as an adversary or an attacker who took over this machine, he has the same single sign-on experience. He can start harvesting your credentials, for example. He doesn't need to create a credential, can use the hashes that he has been able to acquire and then use them to move lateral to other systems. This is what happens all the time if you read analysis of breaches that happen in the wild. It won't take long. After your initial access, you will read that they start harvesting credentials, try to move lateral to other systems, and basically escalate privileges to by harvesting other accounts and getting higher and higher up into the chain of permissions, let's say, to then take over the domain, take down services, exfiltrate data, whatever they're after. So that's what you want to secure, of course. So let's start with a few basic examples. So here, like I said, I'm on the environment. What I can do is open a remote desktop connection, which is on the desktop here, just to another system. This would normally connect and it will provide my credentials to log in. However, what happens now, as you can see, is that I get three applications actually asking me to validate the MFA. I only need to use one, and again, you don't need to apply the all three. You can only use one if you want. I will take the Silverfort app for now, asking me, are you trying to RDP to the system? Right, you can see it's waiting. I say, yes, this is me. And now the connection will continue. So this is a policy that has that triggered from, let me remove the other triggers in the meantime. I don't need them anymore. This is a policy that triggered basically on the fact that I'm trying to do remote desktop to another system. There's a policy for that. There's nothing related to behavior analysis at this moment. It's just that, for example, this is a more critical system. My user is admin. I didn't show it, but I'm an admin account. So I want MFA for this connection either way. Even my credentials are cached, and even if I can log in, I still want MFA approval for this. And again, there's no client on this system in particular to do this. We do this with our integration, in this case with Active Directory. Now you all probably are familiar with classical way of providing MFA, for example, to SSL VPN solutions or to web-based access. Of course, that's still possible. So, for example, here we have a Global Protect client. We can also provide this one just with MFA. I just need to put in my credentials for this one. What will happen here is, again, we don't integrate with Global Protect solution specifically, but we apply the MFA part on the fact that it's LDAP connection to the back, right? So again, Silverfort app will ask me, Global Protect, is this you? Yes, this is me. And now feedback through the IDP level will go back to the fact that I'm connected. So that's a solution you're all familiar with. The only difference here is that we do not do this by integrating with the solution, because then the solution needs provided. We do this, for example, with this case on the LDAP connection in the back. or more specifically the LDAP-S connection that happens. I'm going to log out from this system and go back to the initial system. Meantime, I'm going to clean up the other MFA requests. So what else can I do here? We have, for example, file share. So there's a file share mapped on the desktop. It opens to another system called APP1. Again, when I open this one, a policy will be applied. It will ask me for MFA. This is very unique in this case that even if you want, there would be a solution or you want to do this with an agent, that's impossible because there's no way. We do this on the protocol level. Again, I can use app and I can deny this, for example, say, no, you don't have access. And then my access is just, I get an error message that the share is not accessible. So think in use cases of ransomware trying to spread, it will look for file shares that have been mapped, that are mapped on the system, maybe scan the network looking for file shares and try to access them directly. This will be a typical use case where that access is actually not granted based on single sign-on, but will, for example, provide the MFA request. So how does this look? How does this work? Let's go to a few slides to show you a bit how this all operates in the back. So let me go. I hope this is still visible.
Yes.
Yes. Okay. Cool. All right. So basically, to start with, like I already explained, we're not an identity provider. Let's be very clear. There's one thing you really need to take away after the session is we're not an IDP. We integrate with IDPs. This means that we hook in to everything that is identity infrastructure, so Active Directory, Azure AD, etc. Because we want to look at the authentications, at the access requests coming in, and we want to be able to act on them in case it's required by the policy, right? So users and services are requesting access to specific resources in the environment. They do that through protocols that you probably all know, like Kerberos, NTLM, LDAP, LDAP-S. If we're looking at cloud, we're more talking about SAML or IDC. But we even support Radius because we still see Radius in the field, and an attacker doesn't really care if you're trying to move away from old protocols. If they're still there, they're going to try to abuse them. So we cannot forget about them. So definitely necessary to also support that. And we basically hook into that identity infrastructure based on different capabilities they provide or other ways. So with Active Directory, for example, we have developed together with Microsoft and validated with the Microsoft team a solution to integrate with AD, with domain controllers. But if you look at Azure AD, for example, we do everything through the Graph API. So it really depends on what the identity infrastructure, how it looks like, what's the nature, how it's developed, how it positions itself in an environment. And we are like, the second opinion to this environment, basically. Everything that is coming in is forwarded to us, and then we look at what needs to happen, right? We can allow it and just see it, put it in our dashboard, give you the information on what's going on, but we just allow it. We can also block it. Meaning that even we're not even reaching the level of access verification by group membership, for example. We just block the initial attempt to authenticate to that resource, or we can provide a validation, a step-up validation with MFA, for example. That MFA request is, like I showed you, will go to an MFA application, or it can also, for example, be to Azure AD, where we can use conditional access to do this. It's basically just another step to validate the request, to validate the access. And again, we support different tokens. We also support FIDO, for example, if you're looking for that. So different capabilities there to apply to validate an MFA request. And then the flow continues. Whenever we get the feedback or we get the positive information back, we send it to the IDP, and then the authentication continues, right? So if the authentication is approved by the MFA request, we allow it. If it's denied, then of course we tell the IDP to drop the connection and not let it through. If we're looking at Kerberos specifically, that would mean that the Kerberos ticket would not be delivered, for example, when it's denied. But again, we could sort of say that the top layer of this schematic has no clue that we are in. The client doesn't know it. The server that's trying to reach doesn't know it. The user will know when the MFA is triggered, but the user doesn't see it on his screen or whatever that Silverfort is there. In terms of architecture, bit of a similar schematics. What we do is, like I said, we integrate with the IDPs depending on what it is in different ways. But all the work is done by what we call nodes, right? So these are virtual machines that can be deployed on-premise cloud infrastructure the way you want it. And these nodes basically talk to the IDP. They process all the information. They enforce the MFA policy if necessary through our messaging service, which is a secured service that we mostly host as a SaaS solution. But if you want air-gapped environment, it could be VM as well. Most deployments, it's SaaS based, and it allows the secure communications with cloud providers, with MFA providers, etc. So the nodes really do all the work. They process everything. They apply the policy. They force it. They do the communication between the for example, Active Directory and the node itself and the user. We don't change anything in the flow that happens in your normal environment. We just the nodes process the communication, and they will put the feedback back to the, for example, to Active Directory to allow or to deny the authentication. Everything is managed through a management console. I just showed you a sneak preview already. There you will manage the policy, but you will also see a lot of information of who's reaching or who's trying to reach what resource, if that has been validated with MFA, yes or no. We also look into your Active Directory for any misconfigurations, sort of real time continuously audit. A simple example, we can show you when a new domain admin has been added, for example. So you can check if that is what you expect or not. Typically something that could happen during an attack and someone is trying to get persistency. You could create a domain admin to try to achieve something, and then we would see it instantly because we were looking at information in real time. But this is like architecture. So the nodes are, of course, scalable. We deploy at least 2, right? But most of the time more, depending on size of your environment, geographical positioning, scalability. So the nodes are you can deploy as much as you want. Really depends on the environment, and everything is managed through a management console. And of course, it's very important, but we allow exportation of all the information that we have to your SIM or other solutions to get that information in, not only from visibility and risk indicators I will show you later, but also for example, have been MFAs that have been denied, abnormal activities, stuff like that. So we have a part where we look at the information that's coming in the environment, but we also where you can apply the policy, of course, but we also have a component called a risk engine. It's a logical thing if you think about it. We're looking at the information coming in from authentication request, access to resources. There's a specific part where you can look at that behavior and see if it's normal or not. That's our anomaly detection. It's an algorithm or multiple algorithms, I must say, working with risk indicators and trying to look for things that are just not normal. And if they're not normal, then the policy, for example, can automatically trigger an MFA for that access. If it's the user doing it and he would approve it and stuff just continues, but there has been, at least at that time, an additional verification of that access request. There's also a part where you know that stuff is just not okay. Let's, for example, take Kerberos when it's being downgraded from encryption algorithm to an RC4 algorithm. That's not something you expect. This is typically that stuff that we know from known attacks. known threats that occur in a network, typically when an attack is going on in an environment and you have been breached. That's information that we know that's also directly injected into the risk engine. And then we allow also external risk indicators to be to influence this engine. So we have integrations with EDR solutions. We have integration with Microsoft Defender, for example. Typically useful information when some malicious activity has been seen on an endpoint, that we know that it's there, which users are involved, and that we can raise the risk of that user or that server, so we can automatically apply some MFA request already on specific authentication requests. So this is an example of a few threat indicators. There's a long list, so I didn't show them all here. But just to give a bit of an idea of what we're talking about, we can look for example, authentication spikes. Most of the time, it's always pretty predictable. But when you see a certain spike, maybe it's not normal. Maybe it's an attack, or maybe it's just normal. But in either way, it's okay to ask for an additional MFA request to the user. If it's not him, then you might have just stopped already a big attack, or if it's him, he can just continue when he validates. Bit different, for example, is service account interactive logon. I'll talk about later about service accounts and how we approach them. But basically, service account should not do an interactive logon. Right? When we see this, it's definitely something that is just known, that we can detect without looking at behavior, but it's a known threat, let's say. Then it's again the policy. You decide what you want to do with this. We can go a bit further. We can detect pass the ticket attack. We can detect user account control misconfigurations, and even go like detecting lateral movement and try to secure this. Right? If we go a little deeper on how we detect lateral movements, so our R&D team is working constantly on these risk indicators and on these algorithms to detect more and more in-depth and new type of attacks, of course, all related to identity-based attacks. One of the solutions that we have is an algorithm. It's the Louvain algorithm. It's basically a community algorithm which takes constantly takes all these authentication requests, puts them in a model, and tries to detect based on the probability of communication between users and services, if something is normal, yes or no, and try to detect lateral movement. We have a few interesting articles on our webpage which are published by our R&D team. We even, I think this year, we're gonna release, maybe this year or next year, but we're working on an open source tool, for example, to detect lateral movement based on our research that we're doing. These are very interesting articles already describing a bit on how it works. And our lab tool also has been discussed in a talk on Black Hat last year. Last year we got already 2023, but in Black Hat US 2022, one of our R&D guys went over and discussed the lateral movement detection tool that we have. So hopefully this year will become open source, but it's definitely also integrated in our product, of course. This is an example of what this can do. So this is a bit old example. It's already from 2020, but still, it's still well, what happens here is still applicable. So this attack, it's a SolarWinds attack. I think everybody heard of it and knows about it. But it basically started with initial access to internet-facing application. After that, there was lateral movement through an ADFS server, where then the secret key was stolen, and then the whole thing was compromised, because from there on you can just get access to other accounts with other user accounts, so you can impersonate whatever user you want. Now, where Silverfort can fit in or would try to stop this is basically maybe on the internet-facing app, if there you want MFA, of course, not on the visual here. But then, of course, in the lateral movement part, we would detect it. We could apply MFA there. Same for the ADFS server. If you saw it, there was an integration with ADFS as well. So there you could say, I want MFA for every admin trying to access the ADFS server. So you cannot just exfiltrate or get access and extract the data you want with a compromised admin account, but you could enforce MFA. And then further on, even if you compromised other accounts, you would still have MFA there. All these triggers, even if they are allowed somewhere or bypassed somewhere in somewhere, or the attacker tries to take another path, it would trigger a lot of information in the environment. Risk engine would show up and would definitely show this indicators in the dash. Service accounts are a very important part here, right? Because service accounts are non-human accounts, let's say. So they're used for machine-to-machine communication. They should not be used as an interactive log-on mechanism. Problem there is that you cannot really secure them with MFA because there's no user related to them. So what we're doing is basically 4 steps. We first of all, we start with discovering them based on the authentication information we're getting in. You've seen that all the information is coming in, and this allows us to look at, with our behavior algorithms, at the behavior of these accounts and detect automatically the service accounts and show them to you. So we list them up, and we also build automatic policies. So I will try, if time allows, but I think it will be fine, to do an attack on a service account and show you how we can basically secure this with what we call virtual fencing. After the system I already learned, of course, but at the learning phase, the discovery, the learning phase, we automatically build policies to show you what this service account is doing, and allowing you to secure, to put a fence around that flow of authentications, so that service account cannot be used for other purposes. Right? But service accounts are very easy to attack. Have a very light footprint in the environment when that happens. So yeah, we see a lot of attacks on this part. So very important to secure them. And then finally, we also have I talked a lot about the on-premise environments, let's say Active Directory, but we see a lot of environments. Of course, I think everybody is on a sort of a hybrid system, where we have an on-premise Active Directory linked with Azure AD, for example. What we do there is we extend all what we have on the IDPs that are more focused on prem, and then, let's say, Active Directory, also to the Azure level by implementing or by leveraging conditional access. What Azure does is allowing you to put some proxy-based solutions for your web applications and use Azure as a single sign-on mechanism. The problem is what you do with your on-premise systems, interfaces that are still there and are used by attackers when they compromise or try to attack your environment. We have different solutions there. We have different integrations with Azure, of course. One of the things that we can do there is, for example, use a bridging mechanism and allow you to, for example, validate a remote PowerShell connection also with Azure conditional access. This way, we sort of glue together the capabilities of conditional access also to the on-prem, and together with what Silverfort can provide. And this is a recent example. It's from September 2022. Again, how this would help here is that, initial access was done through VPN solution here. Credentials were stolen from a network share. From that network share, there was a service account that was stolen here. That service account was used to log in to a secret vault, and then basically everything was breached because all the accounts were in the vault, and we was able to access all these cloud services. Right? Looking back at what we do with combining cloud and on-prem and securing service accounts, we basically we have MFA bombing resistance to start securing the VPN. We've seen in the demo that I can MFA a network share, for example. We can MFA service account capabilities. So service account is used for a specific purpose. Interactive logon and using it to log on to a vault would not be possible, as our policy would block it. And then further on, you could definitely also look at cloud and see that if this would not have been captured already, or there's another approach taken, that we would still have that capabilities on the Azure level or on the cloud levels, let's say, to see that something is going on there, and also apply security policies. So that was some information, or a bit of an overview of what we've done, or what we can do, and how we position ourselves. So what I would like to do now in the remaining time is give a few. I hope my just a second. I need to put my phone back in mirror mode here because it dropped out. There we go. What I'd like to do now is just run through a few scenarios.
Maybe if we could hold on for 1 second, there's a couple of questions that we might need to answer live.
I think actually there's a couple of questions, although the demos are always very interesting. I think we're good to answer them. Is to really understand kind of the integration and really understand where Silverfort is a good product to use. We got a couple of questions from both from Pranav as well as from Wolfram. And I think you had a quite good slide that you showed before where you showed kind of the architecture and where it integrates. If you could go back to that.
Yeah, just a second.
I think I've understood it, so let's see if I did or not. So where I see, from my perspective, as running enterprise IM systems primarily for the workforce part, one of the challenges that if you look at more modern systems like Azure AD, for example, modern IDPs, you have quite a lot of things you can integrate to Azure AD Connect, etc. You can do risk management, you can do all kinds of stuff. But then you also have a quite, in many cases, you have a quite large legacy part next to Active Directory. There, it's much harder to find integration points, and there I see it's a very interesting option that once you have kind of created a good setup for your Azure AD for your modern environment, then you still have the choice of, okay, so do I migrate? And it's not uncommon that you have hundreds or even thousands of applications that use your legacy part. And what Silverfort offers, I would say, in this scenario is that you get an ability to at least be able to go in and apply extra security on the critical of those applications in a way that doesn't require the right application. Instead of changing hundreds or thousands of applications, you go into the IDP, which in this case is AD, and you do integration there, and you also have quite good out-of-box integration that you get all the events out of the AD during the authentication to be able to kind of address them. So Wolfram, did that clarify? So it doesn't really do an arbitrary IDP. And instead of integrating with the application, you're integrating with the IDP, which in many cases, of course, if you usually have only a few IDPs, while you might have hundreds or thousands of applications.
Yeah, it also, like, just to be clear, while it does not integrate to any IDP, I'd say we cover about 95% of most commercial IDP solutions through integrations that we have available. Things like Ping, Microsoft Okta, Hyper, Duo, Ubico, you name it. Then we have LDAP integrations. You can even connect with a Radius server as well. So there is, chances are that we integrate with the IDP that you are using. Can I guarantee it 100%? No, we'd have to look. But yeah, I hope that answers the question.
Yeah, I think it's important to remember it's that we're really that second layer, right? The fact that we integrate and we can hold the authentication, so the IDP validates it based on username access, username password validation, maybe some access control on group membership or whatever. It would, in a normal situation, it would allow you then the access. And what we do is we say, hey, wait for us. We want to validate some additional information. That can be a simple policy saying yes or no, can be a policy asking you for MFA, can be a policy linked to Azure AD saying, hey, Azure, I have this access request, can you validate it? True conditional access, for example. So different ways to give information to us. We can look at risk, look at threats that we see. That would change the output of what we're of giving to the IDP to yes, to say yes or no to that access request. So we're not validating authentication based on credentials. We are validating it based on behavior, on risk, and on an additional MFA validation, for example. I see someone is asking if it's a sort of threat and identity threat analytics product. I would say yes and no in that sense. If we go further and we do analytics, we do analysis on what's going on. It's the behavior part. But we also provide the ability to do something instantly. We're not just giving you a red flag in your SIEM and saying, we think something is going on. You need to have an analyst look at it. And then we create a ticket and then go on. We have this, but our policy will trigger direct immediately on what we see, which would give you or save you a lot of time when it's about a real live attack. We have examples of customers who where Silverfort stopped a ransomware spreading in their initial phase, and then when the adversary bit of dropped it, and then later on they still had persistency. They came back, but it was already too late, and the analysts were on top of it and used Silverfort to even secure it more, and then basically saved them time to save their environment. If it wasn't there, then the initial ransomware deployment would have worked, and then yeah, that's another story.
Great.
Sounds good. Do we have any more questions we should take, or should we go into the demo?
What is the overhead authentication layer with existing IDAM solution? David, do you want to do that?
Yeah, so it's a very interesting question because we hear it a lot. That's, I think the answer is on this slide, right? What we do is we hook in with a very lightweight solution on these IDPs, right, depending on what they provide. For example, for Active Directory, we look at the domain controllers, and we have an agent there, or let's say more what we call an adapter that is doing the forwarding for us, but it's not doing anything else. So it's very lightweight because it's only forwarding information. All the work is done on the nodes. So we do everything on dedicated hardened virtual machines because we don't want to influence performance or provide any overhead on this layer. Also, in terms of deployment, this is the only link that we need to put in there, right? So we don't need to redirect the authentications to another platform. I think in deployment, it takes about 4 hours to get these machines up and running, and we're good to go. Information is flowing, and then from there on, you see everything coming in, and you start deploying policies. We're really on the second layer. We're really just there looking at it. We provide feedback to the IP layer to say what they need to do. If we're not there, things just continue as it was. So it's very easy to deploy it and to get started, basically. All right, so let's continue with 2 examples. So the first thing I'd like to do is a simple pass the hash attack. What I will do is show you how you can, you're all familiar, I think we all heard about the tool Mimikatz. So what I will do is I will just drop some credentials from memory. I have a cheat sheet here so I can copy commands. That makes life easy. I just need to make sure that I clean up some information here. That's done. So I already showed that we're in a domain, right? That my user is. Maybe I didn't show that really clear, but let me do that again. You will see that I'm an administrator account. I'm in the build administrator group. I'm a member of other groups as well, but I'm basically an admin, and I'm on this machine. So not really good best practice, but anyway. So what we can do with Mimikatz is drop credentials that are stored in memory, right? So I'll show you a bit how this is done. I'm going to use a one-line command just to make it more easy for me. Let me see. There we are. So one of the things you can ask for is the Oh, this is wrong. I need to be MSV, but anyway, I'll change it. Is ask for everything that is anti-LM based and kernel credentials, so hashes that are stored in memory, right? Whenever you're asking this, this is basically the output that you're getting, right? So we ask for, you need to escalate privilege to debug level, meaning then you can read processes, and then Mimikatz is capable of dropping everything from Alsas. Alsas is the sort of database that is on the system and then stores credentials of everybody logging in, right? So you can see a lot of users here now. Credentials disappear after a while, so you can see that certain users have logged in, but there's nothing in the MSV. My user, however, should be somewhere in this list. It's a bit of searching because it's a shared environment, so all our ICs are using this. So I need to look for my user, and then you will see that the hashes are available. I hope I don't miss it. This is another one. Will be at the bottom probably. Jason coming in, Cameron, Frank. I'm looking for my account. Oh, I'm gonna tag my own account because that's there. No, I'm not there. Whoops, that was me. Sorry. Yeah, there I am. I'm going a bit up again. So here I am. So here you can see my username Davey, so the domain controller that validated me, and you can see that there's an anti-alarm hash in memory, there's a SHA-1 hash, and there's a data protection API hash. So Windows stores these hashes. It used to store plain text credentials in the past, but they kicked it out, luckily. But still, these hashes are there. So this is what is being used when you open that remote desktop connection. A single sign-on is forced, right? So these hashes are used. What I can do now, since I've been able to drop these hashes from memory, I can use, so I'm going to copy this hash and quit from this screen. I'm going to paste it here. This one is an old one. There we go. So this is the hash that I want to use. And from this, I can actually or ask to run a PowerShell command, again, using Mimikatz to another system. So we clear the screen. Unlock my phone. There we go. So the command is basically like, okay, let's do a pass hash. The user is Davey. The domain is AC. I want to run PowerShell, and I need to provide the NTLM hash, of course, which I copied. There we go. So this will open a connection or open a prompt. Let's say, well, this is a new PowerShell. So this is the old one. This is a new PowerShell, and this PowerShell is now running, impersonating my user. Right. Again, I'm doing this with my user because I want to show you how Silverfort MFA will get in my way. This would typically, you would doing this typically with another user account, which makes sense. But for demo purposes, I'm attacking my own user. But this is now running within context of the user that we're attacking. So we dump the hash of his credentials. We don't know his password. We only have the hash. But using a pass the hash method, we're able to open a prompt that is running in that context. And from here on, I can try to open a remote PowerShell connection to another system, for example. In this case, the same system that I used the RDP before. I'm going to open a PS session towards that. However, when I'm trying to do that, MFA is being requested. Right? So this is the way pass the hash it happens, right? However, as a user, I'm getting an MFA request. I'm not doing this. I'm not in the office, whatever I am. I'm like, this is strange. So I do a no, I deny it, and my session is dropped. So in this case, the pass the hash has been stopped, even that normally I should just have the access and being able to log in. I can show you how this
just want to clarify here, because you saw David use here the Silverfort app. This would work as well with any other authentication app.
Yeah, correct. Yeah, I think it really depends on, like we'll show you in a minute that how this looks in the UI, but the policy really dictates what account, what MFA app you want to use, so you can change it per policy rule. For simplicity, I'm using the Silverfort app indeed. So this has now been done using remote PowerShell. We can do the same, for example, for psexec, right? I believe psexec should be here. I hope so. Yeah, psexec. I can go to the same AWS RD16 2. I could try psexec. It's another way of moving lateral. Uses the CIFS protocol, or SMB protocol, I must say. Try to access system using and ask me for a command prompt. Again, I get an MFA request, Silverfort saying, "Hey, are you trying to do this?" I say no again because it's not me, and I get an error message that account restrictions are preventing the user from signing in. So I'm stopping the capabilities of an attacker who did a pass the hash attack, who's trying to use a pass the hash attack to move lateral to another environment just by simple MFA requests to the user that, well, the account owner, basically the one that the attacker is trying to attack. So let's go to the user interface and show you how this all looks like. Let me start off with our investigation page for this user. This is the account. So here you will see sort of a high-level overview of my account. So the account, I must say the account we're attacking, and we'll start somewhere. Let's see, these are the access requests I did. Well, I approved the MFA when I was showing remote desktop. This is where I blocked them, for example. This is where we have a blocked by MFA request to, I believe this was the file share that we accessed. This is high-level overview. I'll go to the logs in a second and show you that you can see the more detailed information that this was indeed file share. I'm just looking for my attack. This is one. So here, this is the attempt where we're actually trying to move to RD16.2, right? And MFA blocked it. After that, risk level was changed from low to medium, right? You can see I'm now on a high-risk user. I was low. It's already changed this from low to medium. If we continue, we'll see that the risk indicator was seen weak encryption protocol. This happens when you're doing the pass the hash attack. So we detected a weak encryption protocol, not something that you should see in an environment, so not really normal. After that, we tried a psexec command. We blocked it. Psexec is a bit more aggressive, let's say, than PowerShell, and trying to do it multiple times. You don't see it, but it's doing it. We do it. We provide auto responses. So we did a one-time block, and then we do auto response. So you don't get how many, like 10 maybe, or 7 or 8 MFA requests. We take them in, and we all deny because it was denied or blocked in the first place. And then after that, we see abnormal MFA activity happened because it was denied again, another interface, another attempt to access using the pass the hash attack, and the risk level was moved from medium to high. So now we can see that my user has a few risk indicators. I'm a domain admin, password never expires. And this influences the fact that abnormal MFA activity and weak encryption has been used. I'm already high risk. Maybe on a normal user, I would be on medium. It depends. It's really all about the algorithm doing its analysis, looking at this activity and giving me a risk level. This now means that other policies would be triggered, right? If I look at more detailed logging information, you'll see similar information, but more in detail. Here, for example, this is the block. You can see it's HTTP has been blocked with Silverfort mobile. So the MFA, the Silverfort action is MFA blocked. IDP result is a deny access. So Silverfort mobile denied it, and we can see which policy it was. If I go to this policy, we get to the policy page. I'm not going to go in detail on the policy, but it basically dictates that for this user access to this system, I want MFA, right? Remark, and it's the only thing I want to show you here, that this is static. If you're looking at risk, the fact that I'm a high-risk user, we could build risk-based policies. I believe, let me check if I have any. No, I'll just use this one. I could change it to risk-based and then say, look, you need to trigger when there's a certain level being reached, or you need to trigger based on a specific indicator. For example, if you see abnormal MFA activity, go ahead and trigger an MFA request for this user because we see stuff that is abnormal. If you see authentication spikes, credential scanning, you name it, stuff that we detected until MP1, If you see that, I want to secure it with an additional MFA request. Typically, you would do this on a full environment, not for one user, but the whole environment. If you see something specific, MFA, just to make sure that it's not an attack, or if it's an attack, that you can stop it. So that's one example. So you have only 4 minutes left, so I want to show you also the service account part. So I explained already.
In the interest of time, I think we don't really have too much time to go into the service accounts anymore yet to go deeper into it. But for people on the call, in the chat, I have posted a link to a feedback form. It's just 2 questions. So please feel free to, or it would help us if you could fill that. Also, and I understand this is not relevant for everybody in the call, because I know we're an international audience, but next month on the 15th of February, for the people that do live in the Netherlands, we are planning to host a lunch with our VP of Product Management. Also, if you are interested at attending that lunch, please use the form to indicate that, and we will send you an invite for it as well. In the form also, you could say if you are living somewhere else, you could also say, leave your email address there, and we will get in touch to provide more feedback.
So a big thank you to Jasper and the rest of the team and Davey for this presentation. At least to me, it was quite interesting, and it is a very interesting option of, especially when it comes to the kind of the legacy, the on-premise Active Directory, because there normally your options are very limited on how to make things more secure. So big thank you. For just a few future things, EIC is coming up in May, as well as few other conferences. So,
yeah, we're going to be at EIC. We're going to be at Gartner IAM. So yeah, lots of events where you can find us.
So thank you very much, and I wish everyone a nice day. And this presentation will also go up on the YouTube channel, so you can get it there if you didn't have time to watch the entire one today.
All right.
So a great one. Great day, everyone.
Thank you.
Thank you.
Bye.
Bye.